welcome to my class. We are already in week number 5 in this school year 2020-2021. Today we will be discussing about the second sequence, which is geometric sequence. Last week you have learned about the first sequence, which is arithmetic sequence. So, are you ready to learn geometric sequence now? Okay, let's go. What is geometric sequence? So before that, let's have first our goals after this lesson. After this lesson, you will be able to illustrate a geometric sequence and you will be able to find the end term of a geometric sequence. Okay, are you ready to learn? Okay, so we have here, what is geometric sequence? How does it differ with arithmetic sequence? So we can say that it is a geometric sequence when it is also called a geometric progression. When we say progression, there is an increase or decrease of the terms in the sequence. And geometric sequence is a sequence in which each successive term is obtained from the preceding term by multiplying it by a non-zero fixed number called the common ratio. I will discuss later how to get the common ratio. Okay? So, also, geometric sequence, it could be finite or infinite sequence. I think you already know what finite sequence is and what infinite sequence is. When we say infinite, it has 3 dots, which we call ellipses. And if you cannot say that in a sequence, that means a finite sequence. Okay, those are the definition of geometric sequence. Okay, did you get it? Let's try to illustrate what geometric sequence is. In the given sequence, 1, 2, 4, 8, 16, and 32. 1 being the first term, 2 being the second term, 4 being the third term, 8 being the fourth term, and so on and so forth. This is an infinite geometric sequence because there you can see the ellipses. Okay, how do we know that this given sequence is a geometric sequence? Here, when you go to the second term from the first term, you multiply it by 2, right? 1 times 2, that is 2. 2 times 2, that is 4. And 4 times 2, that is 8. 8 times 2, that is 16. 16 times 2, that is 32. So, there is a common number being multiplied to get the next term of the sequence, right? So that is what we call the common ratio. Again, common, from the word common, the same. There is a common number being multiplied to all the terms in the sequence. So 2 is the common ratio. Okay? So how do we get or how do we obtain common ratio? To get the common ratio, we will just divide the current term to the previous term. See, for instance, 2 divided by 1, that's 2. 4, which is the current term, divided by 2, which is the previous term, that is 2. 8 divided by 4, that is 2. 16 divided by 8, that is 2. 32 divided by 16, that is 2. So, we can say that the common ratio of this sequence is 2. Let's try to have another example. We have 2, 8, 32, 128, 512, and so on and so forth. Now, how to get the common ratio? We will be dividing the current term by the previous term. So the current term is 8 divided by 2, that is 4. 32 divided by 8, that is 4. 128 divided by 32, that is 4. 512 divided by 128, that is 4. And they have common ratio, therefore 4 is what we call the common ratio, and we can say that this sequence is geometric sequence. So we can say that R is equal to 4, or the common ratio is equal to 4. Okay, so let's try to identify if the given sequence is geometric or arithmetic. Now, what's the difference between the two? When we say arithmetic, it has common difference. Common difference is obtained from subtracting the current term by the previous term, right? While geometric sequence has common ratio. How do we get the common ratio? We will divide the current term to the previous term. Okay? So arithmetic sequence, get the common difference, current term, and by the previous term. Geometric sequence, divide the current term by the previous term. Okay, now let's try to identify. Number 1, we have 2, 10, 50, 250. Now let's try to check if number 1 is arithmetic. Now let's try to subtract. 10 minus 2, that is 8. 50 minus 10, that is 40. They are not common. Therefore, this sequence is not arithmetic sequence. Now, let's try to check if it is geometric. 10 divided by 2, which is 5. 50 divided by 10, that is also 5. 250 divided by 50, that is still 5. So there is common number being the quotient if you're going to divide the current term and the previous term. So we can say that number 1 is a geometric sequence. Okay, so we can obtain the next terms by just multiplying directly 250 by the common ratio, which is 5. Okay, let's try number 2. And that is 250 divided by 50, that is 5. So common ratio denotes R. So R, when you see R, that refers to common ratio. Okay, let's try number 2. 2, 7, 12, 17, and so on. So let's try if it is arithmetic. 7 minus 2, that is 5. 12 minus 7, that is 5. 17 minus 12, that is 5. So we can say that this sequence is arithmetic sequence. Because, when there is a common difference, and the common difference is 17 minus 12, which is equal to 5. Okay, let's try to check if it is also geometric sequence. So we will divide 7 by 2, that is 3.5. 12 divided by 7, that is 1 point something. So they are not common, so we cannot say that. So we can conclude that this number 2 sequence is not geometric sequence. Okay, number 3 here. -2, -6, -18, -54. So let's try to check if this is arithmetic sequence. -6 minus -2, that is -4. -18 minus -6, that is -12. So they are not common, so this is not arithmetic sequence. Now let's try to check if this is geometric. -6 divided by -2, that is +3. -18 divided by -6, that is +3. -54 divided by -18, that is still +3. And we can say that this is geometric with a common ratio of +3. Okay? Next, -10, -20, -30, -40. Well, that is arithmetic with a common difference of -10. Okay, so number 5. 1, -2, 4, -8, 16, and so on. So we can say that this is not arithmetic because -2 minus 1 is -3. 4 minus negative 2, that is positive 6. So they are not common, so this is not arithmetic. So let's try to check if this is geometric. Negative 2 divided by 1, that is negative 2. 4 divided by negative 2, that is negative 2. Negative 8 divided by 4, that is negative 2. Positive 16 divided by negative 8, that is negative 2. So they are common, so that is geometric. And the common ratio, or the R, is negative 2. Okay, I think it's so far so good. I think it's very easy to identify whether the sequence is geometric or arithmetic sequence. Just take note of the common ratio, that's geometric. How do we obtain the common ratio? Divide the current term to the previous term. Arithmetic, subtract the current term to the previous term. Okay, so how do we find the nth term of geometric sequence? So I will be giving you directly the formula of the geometric sequence here. A sub n equals a sub 1 times r to the power n minus 1. Okay, where a sub n is the nth term, your a sub 1 is the first term, r is the common ratio, and n is the number of terms. Okay, so you all need those things for you to be able to solve the geometric sequence, the nth term of geometric sequence. Okay, let's examples. So, like here, write down the 8th term of the geometric sequence. 1, 1, 3, 9, and so on and so forth. So there are only 3 terms given. 1 being the first term, 3 being the second term, 9 being the third term. And you're going to find the 8th term of the sequence. So how do we do that? So we need to use the formula, where the formula is a sub n equals a sub 1 times r to the power n minus 1. So since we're going to find a sub n, that is a sub 8, which is unknown. So your a sub 1 is 1 being the first term. Your r is 3. 3 divided by 1, that's 3. 9 divided by 3, that's 3. And your n is equal to 8. Why? Because you're going to find the 8th term of the sequence. Okay? So let's try to solve. Using the formula, let's substitute the formula. A is n. A is a sub n. Your n is equal to 8, so substitute n by 8 equals a sub 1, which is 1, times your r is equal to 3, so substitute r by 3, then n, which is 8, then minus 1. Okay, next. So we have 8 minus 1, that is 7. So what is 3 to the power 7? When you say 3 to the power 7, that is not 3 times 7, but 3 times 3 times 3 times 3 times 3 times 3 times 3. So there are 7 3's to be multiplied, and that is 2,187 times the first term, which is 1. So we can say that the 8th term of the given geometric sequence is 2,187. Let's go to the next example. So we have here, determine the 5th term of the geometric sequence 5, 5 halves, 5 fourths, and so on and so forth. So let's try to use the formula. Again, the formula is equal to a sub n equals a sub 1 times r to the power n minus 1. So what are the given? So we are going to find a sub n, which is a sub 5. The first term is equal to 5. The r is 1 half. Again, 5 fourths divided by 5 halves, that is 10 over 20, or equals 1 half. And n is equal to 5 because you're going to find the 5th term of the sequence. Now let's try to solve using the formula. So let's try to substitute the formula. A sub n, which is your a sub 5, is equal to a sub 1, which is 5, times r is 1/2 to the power 5 minus 1. So we have 5 minus 1, that is 4. Then just copy 5 and 1/2. What is 1/2 to the 4th power? That is 1 times 1 times 1, that is 1. 2 times 2 times 2 times 2, that is 16. After that, 1 over 16 times 5, that is 5 over 16. You may have that fraction as the final answer, or you may have it in decimal, which is 0.3125. How about number 3 example? Determine the 6th term of the geometric sequence: 8/3, 4/3, 2/3, and so on. Let's try to solve using the formula. Again, let's write out the given for you to be guided. So what is a known? We have a sub n, which is the a sub 6, which is the unknown. Next is a sub 1, which is 8/3. Now how do we get r? So divide 2/3 by 4/3, that is get the reciprocal of 4/3, that is 3/4. Then proceed to multiplication. 2 times 3, that is 6. 3 times 4, that is 12. Reduce to the lowest term, that is 1/2. So r is equal to 1/2. Next, n is equal to 6. Okay, let's try to solve. So using the formula, let's substitute a sub n is equal to 6, that is a sub 6, equals, your first term is 8/3 times r is 1/2 to the power 6 minus 1. Okay, after that, subtract 6 minus 1, that is 5. 1/2 to the 5th power, that is 1 over 32. Multiply that to the first term, which is 8/3, so 8 times 1, that is 8, and 3 times 32, that is 96. So 8 divided by 96, that is 0.08333, and so on, or you may have it in a fractional form. Okay, so that means a sub 6, or the 6th term of the sequence, is 8 over 96, or you may reduce that in the lowest term. Always have your answer in a simplified form. Let's go to the next question. Determine the next 3 terms of the geometric sequence: 2/3, 2, 6. So you're going to determine the 4th term, the 5th term, and the 6th term. Okay? Because next 3 terms. So we have here 2/3 as the first term, 2 as the second term, 6 as the third term. The next 3 terms are 4th, 5th, and 6th terms. Okay, how do we solve that one? We need to get r. So again, in getting r, we will just divide the current term to the previous term. So current term 2 divided by 2/3, that is 3, or 6 divided by 2, that is 3. So we can say that r is equal to 3. So how do we obtain the next 3 terms? We will just multiply 6 by 3, which is equal to 18. 18 times 3, that is equal to 54. 54 times 3, that is equal to 100. Okay, let's try this next example. Determine the next 3 terms of the geometric sequence: 1, 1/2, 1/4, and so on. So we have the first term is 1, the second term is 1/2, the third term is 1/4. We need to find the 4th term, 5th term, and 6th term. So we need to solve r for you to get the next 3 terms. Again, r is equal to 1/4 divided by 1/2. So get the reciprocal of 1/2, that is 2 over 1. Then proceed to multiplication, that is 2 over 4, that is equal to 1/2. Therefore, r is equal to 1/2. So 1/4 times 1/2, that is 1 over 8. 1/8 times 1/2, that is 1/16. 1/16 times 1/2, that is 1/32. Okay, let's go to the next example. Determine the next two terms of the geometric sequence -8, -4, -2, and -1/2, and so on and so forth. So we need the fifth term and the sixth term. So in order to find the two terms, we need to have R. Again, R is, you're going to divide the current term to the previous term. So the previous term is -4 divided by -8, that is positive 1/2. So if you have already R, so you will multiply that to -1/2, which is the fourth term. So -1/2 times 1/2, that is -1/4. And -1/4 times positive 1/2, that is -1/8. Okay, let's have a problem. The last example. So a ball is dropped from a height of 300 centimeter and bounced back 200 centimeter, and then again bounced by 243 centimeter, and so on. How high will the ball reach after the seventh bounce? So this is now the given sequence: 300, 270, 243 until to the seventh bounce. So your A sub 7 is unknown. Your first term is 300. Your R is 0.9. So 243 divided by 270, that's 0.9. And your N is equal to 7. Okay, let's use the formula. A sub n is equal to A sub 1 times R to the power n minus 1. Okay, substitute the given formula. A sub, your n is equal to 7, so A sub 7 equals, your first term is 300 times your R is 0.9 to the power n, substitute by 7, minus 1. So 7 minus 1, that is 6. So what is 0.9 to the power 6? That is 0.531441 times 300, that is 159.43 centimeter